All right, hello everyone, welcome. So again, I am not in class today, unfortunately, due to the due to a professional development meeting that I am at the district office. So I left you this video to kind of go over some examples using the exponent rules that we talked about yesterday. So I am going to run through the examples on the organizer real quick, and then in the video, I'm also going to touch on some of the examples from like the full note sheet that's on Schoology. I would recommend putting the other examples I go over, maybe at least a couple of them, in this additional problem section down here, just because that's going to be beneficial to have, because I think having more examples of using these exponent rules on the right is good, right? And as a note, we're going to use multiple of these properties in the same problem. So you really want to be familiar with these properties over here that on the right that we are going to be using together in the same problems today. Okay. All right. So let's start with the first one, simplifying this first one using the exponent rules on the right. So as a reminder, you can only simplify and use these exponent rules when the bases are the same. Notice how all these have the same base in the rule, right? A and A, right? If I'm dividing or multiplying, they need to have the same base in order to do these rules. So, for example, I'm going to simplify the constants together, the x's, and the y's, and that's going to help me get my answer. So you have to only do these rules with terms that have the same base. So what I have is -3/9. So the first thing I'm going to do is simplify those numbers in front. You can take a 3 out of both of those, and those numbers can be simplified to -1/3. So I did that because -3/9 simplifies to -1/3. Then I have x to the first up here and x to the third. Reminder, if you divide two terms with the same base, different exponents, you subtract their exponents from top to bottom. So that's x to the 1 minus 3. And then same thing here. We have y to the first divided by y to the -4th. So it's y to the 1 minus -4. Okay? So when you divide same bases, you subtract those exponents. So then I have -1/3. The x becomes x to the 1 minus 3, which is x to the -2nd. And then I have 1 minus -4. Remember, when you subtract a negative, it's the same thing as addition. So 1 minus -4 is just 1 plus 4, which is y to the 5th. Okay? And then finally, to fully simplify your answer, remember, if you have an exponent that is negative, right, you want to create a positive exponent, which is what we want for a fully simplified answer, we move this term to the other side of the fraction. So I'm going to write this as -1 y to the 5th over 3x squared, and that is my final answer. Okay? So again, you only apply the rules, the subtraction and addition rules with multiplying and dividing, to terms that have the same base. Because you want to make sure that you only do like x to the first minus 1 minus 3. Don't subtract like this 3 and this 4 because they have different bases. Okay? All right. So now we're going to move on to the next one, which is this one. So this rule, if you look down here, when you have an exponent on the outside, actually this one is more applicable here, you want to distribute that exponent to all the terms that are in the parentheses. So we're basically going to distribute this 2 to all of these terms right here, all 5 terms. So, and remember, when you distribute an exponent into another exponent, you multiply those together. So what I'm going to do is I'm going to do x to the 2 times 2, y to the 5 times 2, and z to the 1 times 2, because this was z to the first originally. Okay, so I'm just multiplying all those exponents by 2, and then in the denominator I'll have 2 squared, and then I'll have x to the 3 times 2. Now I'm just going to simplify everything. X to the 2 times 2 is x to the 4th, y to the 5 times 2 is y to the 10th, z to the 1 times 2 is z squared, over 2 squared is 4, x to the 6th, 3 times 2. And then before we can say we have a final answer, you want to check, do you have any terms that you could simplify further? And I do see 2 terms that have the same base, and so that means I can simplify them together. So remember, if we're dividing x to the 4th by x to the 6th, that means we can subtract those exponents, so x to the 4 minus 6. Everything else doesn't have there's no other term with a y or a z, so everything else is going to stay the same. And so x to the 4 minus 6 would be x to the negative second, y to the 10th, z squared, over 4. And so again, if we want to make this term not have a negative exponent, we take this and we move it to the other side of the fraction. So this becomes y to the 10th, z squared, over 4x squared. That is our final answer, okay? So remember, you can only do these rules with terms that have the same base, okay? And these are the two from the organizer. You might have already had these. If so, great. If not, make sure to copy them down, okay? And so if you need a second to copy it down, pause now, and we're gonna move on to the couple on the note sheet after you're done writing these down. Okay, so let's get to the ones on the note sheet. So I'm going to do example 2, just because example 2 has a couple of things that I want to highlight. And so this is the note sheet. Again, you don't need to worry about where that is. You can just copy this down. Okay, so the first thing I'm always going to do is try to simplify the coefficients in front. I'm going to ask myself, can I simplify the fraction of negative 20 over 45? Is there a number I can divide both of those values by? And yeah, I can. I can divide both those numbers by 5, actually. I can divide negative 20 by 5, get negative 4. And I can divide 45 by 5 and get 9. So that's fraction in the front simplifies to negative 4 over 9. So that's good there. Then I'm going to follow my rules for like bases. I see a pair of like bases on opposite sides of the equal sign right here, this a and this a. So I'm going to, if I'm dividing them, I'm going to subtract their exponents. So a to the first minus 5, a to the 1 minus 5, because I'm subtracting a to the first minus a to the fifth, right? And then what else I can do is there's a negative here for the b, so I can move it to the other side of the fraction in order to make it positive b to the fifth. And then finally, there's this c to the 0 right there. So c to the 0, or anything to the 0 power, is just 1. So you could write times 1 here instead of c to the 0, but really, if something is times 1, it's kind of that placeholder number, right? It doesn't really need to be there. So if I see a c to the 0, I'm just going to kind of just tell myself, okay, I can just kind of just get rid of that, right? Because it's just 1, and 1 is kind of a placeholder number. I don't really need to put 1 in my expression, okay? So now I'm just going to simplify everything in the numerator and denominator. So I have negative 4. A to the 1 minus 5 is a to the negative 4 over 9, b to the fifth. And then again, if I have a negative 4 here, I don't want that to be negative, so I have to move it to the other side of my fraction to make it positive. So I have negative 4 left alone on top. And now I have 9, a to the fourth, b to the fifth in the denominator, and I am done. Okay? And so the only thing I wanted to add to that one, the reason why I did this one, was for that c to the 0 part, right? You can put the times 1, it's not wrong, but remember the times 1 is basically kind of a placeholder there, so it kind of goes away in a sense, okay? All right, so that's that one. I have 2 more I want to do with you. I'm going to do number 3, because I want to just remind you that you should always be careful to distribute. If you do have those parentheses and you're raising everything to a power, you have to distribute that exponent to all of the terms in the parentheses. So we have 4x squared and we have y to the first, right? So remember, if you don't see an exponent, there's a 1 there. Okay? So what this is actually is this is 4 to the negative second, x to the negative second, 4 to the negative second, negative 2 times 2 is negative 4, so x to the negative fourth. And then 1 times negative 2 is negative 2, so y to the negative second. And to make these all positive, because I can't have them be negative, right? I can't do that. I have to move them all to the other side of the fraction, because right now you could basically write them all over 1. So I'm going to move all of these terms, all of them, I'm going to move all of them to the denominator, because they're all negative. So now I have I have 1 left alone on top, because when you move everything to one side of the fraction doesn't go away. It just means there's a 1, right, in place of what was there. So you have 1, you have 4 to the positive second now, x to the positive fourth, and y to the positive second. And the only thing you have to do is make sure to simplify all all expressions that can be simplified, like 4 squared. 4 squared can be written as 16, so 16x to the fourth, y squared, and boom, that's done. Okay, so I just want to remind you, 1, to make sure you move anything with a negative into the other side, and even though all of these left the numerator, it still was a fraction. The numerator just had a 1 in it. Okay, all right, so that was the second to last one. Now I'm going to move on to the last one, number 8. So this is just multiplication, and I wanted to just remind you about how multiplication works. So what we're going to do is we're going to multiply these as if we would multiply fractions. We're going to multiply everything across the top, across the bottom, and then simplify as our final step. Okay? So you're going to multiply all of the like terms together. So I'm going to multiply the constants together. So 6 times 8. I'm going to multiply the x's together. So x to the fourth times x to the first, that's what this is. And then I'm going to multiply the y's together. So y to the second times y to the fifth. I'm going to do the same thing in the denominator, right? Multiply these together, 4 times 3. Multiply these together, x to the first times x to the third. And then I have y to the second times y to the first. Boom. I just rewrote everything so that I could easily see what I'm multiplying together. And now I'm going to simplify. 6 times 8 is 48. And when we multiply like bases with different exponents, that's when we add. So up here, when I did a to the first, a to the 1 minus 5, that was because I was dividing these two. But if I'm multiplying them together, I add their exponents. So that would be x to the 4 plus 1 and y to the 2 plus 5. Down here, 4 times 3 is 12. I have x to the 1 plus 3 and y to the 2 plus 1, because again, I am multiplying those like bases together. I am not dividing them this time, so I'm not subtracting. And then I simplify everything. 48 divided by 12, well, you can divide both those numbers by 12 and you would get 4, or 4 over 1. So that means that this simplifies to 4 on top. And you could put the 1 on the bottom, but again, 1's kind of a placeholder number, so I'm not really going to worry myself with having it there. X to the 4 plus 1 is x to the 5th. Y to the 2 plus 5 is y to the 7th. X to the 1 plus 3 is x to the 4th. And y to the 2 plus 1 is y to the 3rd. And now the final step is, notice how we have division again, these two and these two, right? That we're dividing like bases. So I am going to write my 4 down, and now I'm going to remind myself of the rule. For these, I am subtracting the exponent, so I'm going to do x to the 5th minus 4, and then y, right here, y to the 7th minus 3 over 1. And so what does that become? That becomes 4. X to the 5 minus 1 is x to the first. And y to the 7 minus 3 is y to the fourth. You could put it over 1, but you don't really need to. And that's the answer. Okay, so this one reminds you that when you multiply, you add. And when you subtract, or when you divide, you subtract the exponents. Okay? And those are some of the examples I wanted to show you. Okay? All these other examples are posted in the key on Schoology. But again, exponent rules will come up in lessons where we also do solving radical equations and things like that. So you're going to want to make sure that you're comfortable with this as well. Okay? All right. If you have any questions, please let me know. You are working on homework 12 tonight, I believe. Yep, homework 12. So make sure you get that done. And then we won't have our next quiz until Tuesday of next week. Okay? All right. I will see you all tomorrow.